In this video, we're going to use the law of cosines to find a missing angle measurement. It's always a good idea to make a sketch of your triangle right away, even if it's not to scale. And so I know that side B is 8 kilometers. Across from side B would then be angle B. Side A is 9 kilometers. Same thing, across from side A would need to be angle A. And then the last side is T, which is 16 kilometers. So there's T there. So we're going to use the law of cosines to find, it looks like angle T. So I am searching for this angle. And we've rewritten the law of cosines to make it easier to find angles. And so we would write this as the cosine of the angle that we're looking for. Take the sides that are not across from it squared and add them together. Subtract the side across from the angle that we're searching for squared, all divided by 2 times those other two sides. From here, you could type all of this into your calculator. To avoid making any small calculating error, it may be a good idea to do the numerator and the denominator separately. So you could take 8 squared plus 9 squared minus 16 squared. And we end up getting negative 111. Divided by 2 times 8 times 9, and so that will end up giving us 144. From here, we know that when we're searching for angles, that we have to take the inverse, and so T will be equal to the cosine inverse of this ratio. Now, keep in mind, when we were solving equations in previous chapters, something like this would have 2 potential answers. Cosine is negative in the second quadrant and in the third quadrant. This answer will end up being angle T. However, we don't care about this potential answer because it is greater than 180 degrees. We also don't care about this potential answer because it's a negative angle. And so now that we're looking at these angles in terms of triangles, these other 2 answers are no longer something that we have to consider. So to find angle T, we'll take the cosine inverse of that ratio, and we will get negative 111 divided by 144. Making sure you're in degree mode, we will get an angle for T to be about 140.429 degrees. It's always a good idea to make sure that your answer is reasonable. And since this is my longest side, it would make sense for this angle to be the largest angle, the obtuse angle in the triangle. We're going to do another example using law of cosines to find an angle. And this is going to be a little bit different than the previous one. Same thing, we'll start by labeling. So we have one side is 4 yards, that would be side G. Y is 7 yards across from angle Y, and then side P 12 yards across from angle P. So we are searching for angle Y. So I'm going to start cosine of angle Y will equal the other 2 sides, 4 squared plus 12 squared minus 7 squared, divided by 2 times the 4 and the 12. From here, I'm going to simplify this fraction. So I will have 4 squared plus 12 squared minus 7 squared. So in my numerator, I'll end up with 111 divided by 2 times 4 times 12, which will end up giving us 96. Now, we normally would take the cosine inverse of 111 over 96. However, hopefully you already are thinking that this isn't going to work, and we are going to get an error. This ratio is larger than 1, and we know that sine and cosine can never have a ratio larger than 1, since this is supposed to be what is the normal hypotenuse, and this would be the adjacent side. This means that there is no triangle. There is no angle. And so even though we drew our triangle, it's not going to work. And the reason behind that is these 2 side lengths, the 4 and the 7, the sum of those is less than the longest side 12. So if you imagine taking the 4 yards and putting it on a straight line with the 7 yards, they can't even make a straight line to get to 12 yards. And so we're going to be 1 yard short. So imagine if we're then moving them not in a straight line, there's no way for this triangle to even exist. And this is where you would see that, so there'd be no angle because there's no triangle.